Question 2. State why the student should use sodium hydroxide solution rather than water for the final rinse of the burette. This one makes a lot of sense, the mark scheme for this one. It's the idea that use of water would dilute NaOH. Use of water would dilute the sodium hydroxide / change concentration of. Use of water would change concentration of sodium hydroxide. Then it says complete table 2. Well, all we're going to do is subtract them. So final reading, start reading type 25.2. Here's going to be 23.90, not 23.9. So both of these two decimal places, whereas here it's just one decimal place. Here's going to be 23.70, and here's going to be 24.00. I have to find the mean titer using concordant results. Concordant results are titers that are within, concordant titers that are within 0.1 centimeters cubed of each other. So which ones are within 0.1 centimeters cubed of each other? This one and this one. So all we're going to do is going to be 23.90 plus 24.00 divided by 2, because we've got two results, two titrations, and that will give me 23.95 centimeters cubed. 2.4. The total uncertainty when using the burette is 0.15 centimeters cubed. Calculate percentage uncertainty. Percentage uncertainty is going to be total uncertainty over the reading of the burette. And now it says use your answer to question 2.3, and that's our answer, so therefore it's going to be 23 divided by 23.95 times by 100. So it's going to be total uncertainty divided by reading times by 100, and 0.15 divided by 23.95 times by 100, 0.626%. 2.5, use your answer to question 2.3 to find the mass of citric acid dissolved in that. Well, this is the 2.3. Well, that is the mean titer. So what we can do, the mean titer with the sodium hydroxide. So what we can do now is we can find out the moles of sodium hydroxide. Then what we're trying to find mass of citric acid. Then we can find out the moles of citric acid. 1 to 3 mole ratio, and then moles of mass of MR, mass equals sum of MR. So let's do that. Moles of sodium hydroxide. Well, it's going to be 23.95 using the answer to question 2.3 divided by 1000 times by, what was it, 0.0500 moles per dm minus cube sodium hydroxide solution, 0.0500. That will give me a moles of 1.1975 times by 10 to the power of minus 3. However, now we need to read the question properly. It wants the mass of citric acid dissolved in this much of the solution. What we found out is the moles of 25 centimeters cubed sample of the solution. So what we need to do now is times the moles by 10. And we also need to divide the moles by 3 because of 1 to 3 mole ratio. So we need to times by 10 and then divide by 3. And that will give me 0.00399 moles. And let's label that as the citric acid. So the examiner knows what's at the moles, what's the moles of that is. And therefore moles of mass of MR, mass is going to be the moles times by the MR of citric acid, which is 192. Now that will give me 0.7664 grams, but we want it in milligrams, so we need to times by 1000. 1, 2, 3, 766.4, 766 milligrams is the final answer. Then it says calculate percentage purity of the sample of citric acid. Well, we'd first dissolve this much of impure citric acid. Therefore, all it's going to be 766 divided by 784 times by 100. Pure over the whole impure solution at 10 by 100, which will give me 97.7%. And that is the end of question 2.